Storage of solar energy. An energy storage system stores the collected amount of energy in excess of requirement of the demand and supplies this energy when the demand crosses the supply energy. The optimum capacity of the energy storage system depends upon the following factors. First one, the expected time dependence of the solar radiation ability and availability. So ability and availability of the time is the main factor for the energy storage system. Next one is the nature of load to expected on the process. So nature of load is also the vital factor for energy storage system. Next, the degree of reliability required for this process. Next point, the size of the solar thermal power system or solar electrical generation. So the size of the power plant and the electrical generating station and other system is play a vital role for the energy storage devices. Next, the cost per kWh of the stored energy. Cost is the main factor for the energy storage system because initial cost is always controlled by the overall project. Next, the environmental and safety consideration. If the system is environmentally reliable, that means the eco-friendly, then that is beneficial for us. Now the solar thermal energy storage system. Thermal energy can be stored in well insulated fluid or solids. Thermal energy stored is essential for both domestic water and space heating devices. Thermal energy can be stored either as sensible heat or latent heat. In sensible heat storage, the temperature of the medium changes during changing and discharging of the storage. In latent heat storage, the temperature of the medium remains more or less constant since it undergoes a phase transformation, that is transition from the solid to liquid or the form of liquid to the vapor. Thermal energy stored in the storage of energy by heating, melting or vaporization of material, and the energy becomes available as heat. So the thermal energy stores are two types. One is the sensible heat storage, another is the latent heat storage. Now first one is the sensible heat storage. The storage by causing a material to rise in temperature is called the sensible heat storage. The quality of heat stored is proportional to the temperature rise of the materials. In sensible heat storage system, energy is stored by heating a liquid or a solid in such a system that the following materials are used, like water, solid like rock, etc. Now, the choice of material used depends on the temperature level of its utilization. That means water is used for temperature below 100 degrees centigrade, whereas bricks can be used for temperature up to 1100 degrees centigrade. Now the basic equation for an energy storage unit operating over the finite temperature difference is Qs equals to m integration of T1 T2 dt, where Qs is the quantity of heat stored, m is the mass of the storage materials, T1 T2 is the initial and final temperature respectively, Cp equals to the specific heat of the storage materials. If V, rho and Cp are the volume, density and specific heat of the storage materials, the energy storage Qs is given by Vp integration of T1 to T2 Cp d into T. Now the storage with water. The earliest way and easiest way to store thermal energy by storing the water directly in the well insulated tank. For flat plate collector system, the optimum tank size is about 70 kg per meter square. Water is superior because of its low cost and low volume required per unit of energy storage. Now, the latent heat storage system or phase change. In this system, heat is stored in a material when it melts and extract from the materials when it freezes. Heat can also be stored when a liquid changes to gaseous stages. But as the volume change is large, such a system is not economical. So this system is not economical due to the volume changes. The following materials which melt on heating and suitable for solar energy operation. There are different types of material. First one is the organic materials. Paraffin wax. It has high heat of fusion, that is 209 kilojoule per kg, and is known fridge without intercooling system. Now the next is fatty acids, is also the organic materials. Next one is the hydrated salt. Calcium chloride hexahydrate, that is CaCl2 6H2O, sodium sulfate decahydrate, that is Na2SO4 10H2O, is melted at 32 degrees centigrade with heat of fusion of 241 kilojoule per kg. The reaction is like that: Na2SO4 10H2O, then the result is NaSO4 plus 10H2O. Here some amount of energy released and energy storage is also there. Now, inorganic materials: sodium nitrate NaNO3, sodium hydroxide NaOH. Next part of the storage is the electrical storage. The electrical storage is mainly based on the battery storage. A rechargeable storage battery, like secondary battery, a group of interconnected cells. So battery is the secondary batteries, and which is the combination of a group of interconnected cells. So this rechargeable battery receives electrical energy as a direct current, which is stored in the form of chemical energy by a electrochemical reaction, and this reaction is basically the reversible reaction. The capacity of battery is given in terms of ampere hour on discharge. This determined by the following factors. First factor is the final limiting voltage of the cells. So these are the specific voltage for a particular cell. Next, discharge rate. The discharge rate is also the main factor of the battery storage. But by the help of this rate, we can ensure the operating time of a particular load, which is depends upon the battery. Next point, number, design and dimension of the plates. Next point, design of separators. Next, temperature, etc., and the density of the electrolytes. The efficiency of a battery is defined as the ratio of the output of the battery to the input required to store the initial state of the charge under specified conditions of temperatures, current rate and final voltage. For example, different types of secondary batteries are lead acid, nickel, cadmium, sodium sulfide, etc. Now, the number of times the battery can be charged and discharged under specified condition is called the life cycle of the battery. The life cycle of a battery may vary with depth of discharge, deep discharge tendency to result in short cycle of life. Now, the capacitor storage system. In this process, the capacitors are used to store a large amount of electrical energy for fairly long period. The total energy stored is given by the total energy stored CAP equal to half V epsilon E square, where V is the volume of the dielectric, epsilon is the permittivity, that is constant, and E is the electric field strength. The capacity store energy at high voltage and low current.